In problem 154, we have this car which is moving to the right, car A, and with the velocity of 18 kilometer per hour and acceleration of 3 meter per second. And this Ferris wheel, it is rotating with the constant angular velocity of 3 revolution per minute. And we have someone which is sitting on one of these seats at point B. This angle is 45 degree. So this guy at the moment is having velocity of r times omega, right? The velocity of a particle which is moving on the circle with the angular velocity of 3, or in general alpha, omega is going to be r times omega, right? And it's going to be in the tangential direction. So we have the velocity of both of them. And we want to find the relative velocity and acceleration of A with respect to B. So if I want to start with the equation, velocity of A with respect to B is equal to velocity of A minus velocity of B. Velocity of A, we know it's all in the x direction, but the velocity of B is equal to r times omega. This is capital omega. And it's going to be in this direction. This angle is 45 degree. So 45 degree below x-axis with the magnitude of r times omega. So velocity of A with respect to B is going to be velocity of A, which is 80 kilometer per hour. And we need to make it meter per second, which if you divide it to 3.6, is going to be in meter per second. And it is all in the I direction. Minus velocity of B. You can write the velocity as magnitude times the direction. The magnitude is r times omega. R is 9. And omega is given in revolution per minute. We need to change it to radian per second. So it's going to be equal to 3 times. Each revolution is 2 pi radian, and minute is 60 seconds. So omega is going to be 3 times 2 pi divided by 60, or it's going to be equal to pi divided by 10 radian per second. So let's go back to the equation. We have r times omega, so r times pi divided by 10, which is omega, times the direction. And this direction, the unit vector in this direction is going to be cosine of 45 in the I direction minus sine of 45 in the j direction. So cosine of 45 in the I direction minus sine of 45 in the j direction. And if you calculate the numbers, velocity of A with respect to B should be 3.00 in the I direction plus 1.999 in the j direction, meter per second. So this is going to be the velocity. For acceleration, we have the same process. Acceleration of A with respect to B is equal to acceleration of A, which is given, minus acceleration of B, which we need to calculate it. Acceleration of A is 3 meter per second squared, all in the x direction, minus acceleration of B. The speed of B is constant because the rotational speed, the angular velocity, is constant. It's not changing. But whenever you have a point which is moving on a curve, here it's a circle, we are going to have two acceleration. Acceleration in the tangential direction, acceleration in the normal direction, just to remind you. Acceleration in the tangential direction, if you remember, it's equal to v dot, change in the speed. But v is constant here. The velocity is not changing. So there is not going to be any acceleration in the tangential direction. Acceleration in the normal direction is equal to velocity squared divided by rho in general, if you remember this equation. And if you are on a curve and if you have velocity, then for sure you're going to have acceleration in the normal direction. So here, in this case, we are gonna have acceleration in the normal direction. There is no acceleration in the tangential direction. And the magnitude of that is gonna be velocity squared divided by r. So we are gonna have velocity of b squared divided by radius of curvature, which is r here. And it is in this direction. So magnitude times the direction. What is the direction here? It's going to be cosine of 45 in the j direction, cosine of 45, cosine of 45 in the negative I, cosine of 45 in negative j. So we are going to have negative cosine of 45 in the I direction, negative sine of 45 in the j direction. Velocity of b is this. Let me write it again. Velocity of b is r times omega, or it's equal to 9 times pi divided by 10. We can replace VB with this. So if you do that and do the math, then acceleration of A with respect to B is going to be equal to 3.63 in the I direction plus 0.628 in the j direction meter per second square.